Why is Nyquist-Shannon important for DAC? Imagine trying to recreate a song from just a few tiny snapshots. Without the right rules, the music might sound off or even wrong. That's where the Nyquist-Shannon theorem comes into play. It is a key idea in digital to analog conversion, which turns digital signals into smooth, continuous analog signals. When engineers design digital systems, they need to know how fast to sample the digital data to make sure the sound or signal stays true. The theorem says that the sampling rate must be at least twice the highest frequency in the original signal. This minimum rate is called the Nyquist rate. If the sampling is slower than this, the reconstructed signal will have errors called aliasing. Aliasing makes high-frequency signals appear as lower frequencies, which distorts the output. Think of it like a mirror reflecting an image incorrectly. If you don't follow this rule, the final sound or signal will be distorted and not match the original. In digital electronics and embedded systems, this rule guides how fast the digital samples are converted back into analog signals. For example, in audio systems, if you want to reproduce sounds up to 20,000 Hz, you need a sampling rate of at least 40,000 Hz. That's why audio CDs use 44,100 samples per second. This rate covers the entire range of human hearing and prevents aliasing. After the digital to analog conversion, engineers use special filters called low-pass reconstruction filters. These filters smooth out the stepped waveform created by the digital samples. Without these filters, the output would look like a staircase, which is not what we want. The filters remove the high-frequency images that sampling creates, leaving a clean, continuous signal. The importance of the Nyquist-Shannon theorem extends beyond audio. It's vital in communication systems, control systems, and any place where digital signals are converted to analog. If the sampling rate is too low, the system produces distorted signals, which can cause errors or poor performance. When designing a digital to analog converter, engineers always check the highest frequency component of the signal and set the sampling rate accordingly. In embedded systems, this means carefully choosing the sampling frequency and filtering to match the signal bandwidth. For instance, in video or sensor data, the same rules apply. The goal is always to avoid aliasing and keep the output faithful to the original signal. So, in simple terms, the Nyquist-Shannon theorem is the rulebook for making sure digital signals become accurate, smooth analog signals. It keeps our music, videos, and signals clear and true to life.